The Lucy spacecraft will be taking a journey where no other spacecraft has gone before: the Trojan asteroids. The Trojans are two groups of asteroids that lead and trail Jupiter in its orbit around the Sun, and they've been trapped in these stable locations for over 4 billion years. Lucy will have a suite of scientific instruments for collecting data as it flies by the asteroids. LaLaurie is a long-range reconnaissance imager. It's often referred to as Lucy's Eagle Eyes, since it has the highest spatial resolution of all of Lucy's cameras. This black and white camera is actually a type of telescope, the same kind as the Hubble Space Telescope. LaLaurie was built to produce clear images of the Trojans' craters, which will be a challenge since the Trojan asteroids are extremely dark. LaLaurie will be able to see 75-yard wide craters from over 600 miles away. That's like standing at one end of a football field and being able to see a fly at the other end. The instrument's simple design does not use optical filters and includes no moving parts, reducing the risk of part failure during the mission. LaLaurie will also search the Trojans for evidence of any rings and new satellites. The instrument's ability to see faint targets from far away also makes it perfect for optical navigation. LaLaurie will help Lucy navigate to a point in space, and then a terminal tracking camera aboard the spacecraft, known as T2 Cam, will help the instruments accurately point towards the targets. Lentz is Lucy's thermal emission spectrometer, which detects far infrared radiation emitted by the asteroids due to how they are heated up by sunlight. Lentz detects this radiation using a small telescope to focus the incoming energy onto a detector, similar to the way a remote thermometer works. So, Lentz is not taking images, but rather temperature measurements at various points on the asteroid. This data will be combined so that scientists can get an understanding of its surface properties. Lentz will examine the properties of the regolith on the surface by measuring thermal inertia, which is the measure of how slowly the asteroid heats up from sunlight and then releases that heat. By taking the temperature readings at different parts of the asteroid, the Lucy science team can measure the thermal inertia and figure out how much dust, sand, or rock is present on the asteroid's surface. That data will tell us a lot about how the asteroid was formed, providing insight into the history of our solar system. Lucy's LaRalph instrument will search the Trojans for organics, ices, and hydrated minerals, and will help determine the surface compositions of the asteroids. LaRalph is actually two instruments in one, and together they will measure and analyze the spectra of light absorbed and reflected by the asteroid. The first is a color visible imager, the Multispectral Visible Imaging Camera, or MVIC. It takes visible light color images of the Trojan asteroids. The second is an infrared imaging spectrometer, known as LISA, the Linear Etalon Imaging Spectral Array, which collects infrared spectra of the asteroids. Like LaLaurie, LaRalph does not have a focusing mechanism. Instead, it is designed to stay in focus despite the extreme temperature differences in space by being made almost entirely from a single block of aluminum. Using one material throughout the instrument means that if a part expands or contracts, the other parts will expand or contract at the same rate, helping to keep LaRalph in focus. Even the mirrors are made of aluminum, finely polished with diamond dust. Due to the massive size of the images LaRalph will be taking, the instrument will have around 256 gigabits of onboard memory. And while the LaRalph instrument aboard Lucy does require substantially more power than its predecessors on other spacecraft, it will still not use more energy than your average ceiling fan. In addition to these three main science instruments, other experiments aboard the spacecraft will help fulfill the mission. Lucy will use its high-gain antenna to communicate with Earth for an additional radio science experiment to determine the masses of the asteroid targets. Lucy will also be able to use its two terminal tracking cameras, or T2 Cam, to track the asteroids during the flybys, keep them in the field of view, and to take wide-field images so that we can better determine their shapes and perhaps discover new asteroids nearby. As you can see, the Lucy spacecraft has a large suite of tools to study the Trojan asteroids, which will help us better understand the formation of our solar system.